Okay, we have here today a pretty interesting looking problem. We've got the integral from 0 to pi over 2 of sine the 2023x times cosine 2021x dx. Okay, the thing that got my attention here is I've done this integral, I think I've done this exact integral maybe with sine 2023x, but without the cosine. And I've done things really similar to cosine 2021x. I think recently we had one that was 2023x. I don't think I've ever done this with both the sine and cosine with them both having a large exponent. And of course, the way I wanted to approach this is with the beta function. Okay, now we have our formula here for the beta function, and you may notice there's a bunch of different formulas we can use for the beta function, but this one works well for us because we've got the sine and cosine, so this is going to match up nicely. And one thing I'm going to do with this though, we have this 2 in front, we don't have the 2 there, so real easy, I'm just going to divide by 2 on both sides, and then we'll have a half out front here. And the nice thing about this is it's actually really easy to use because we just need to kind of match up our exponents. We have 2023, and that's going to be the same thing as our exponent here. And 2021 needs to be the same as this exponent here. Once we have our z1 and z2 value, we can go right to calculating this answer in terms of the gamma function. So starting with our 2023, we're going to say that this exponent 2 to the z1 minus 1 is going to be equal to 2023. And just solving for our z1, we find that that's going to be 1012. And then doing the exact same thing on our cosine, we're going to say 2 of z2 minus 1 is going to be 2021. Then solving for our z2, this is going to be 1011. One interesting thing about this formula, you notice it really doesn't matter which exponent's on the sine and which is on the cosine. If we switched our exponents here, if we switched our z1 and z2, just notice that here it's not going to make any difference to our answer. But now with this value and our z2 value, we've got everything we need to go to a solution. So just plugging in over here, we're going to have 1/2 in front, gamma of z1, which is 1012, and then gamma of z2, which is 1011. And then we just have the sum of these two numbers, which is just going to be gamma of 2023. But now for the gamma function, we have a way to just express this in terms of factorial. So if we have gamma of n, we can just write this as n minus 1 factorial. So for each of these values, like gamma of 1012, this is the same thing as 1011 factorial. And gamma of 1011 is going to be the same thing as 1010 factorial. And for gamma of 2023, this is going to be the same thing as 2022 factorial. So plugging this into our solution, we'll just have 1/2 in front. For our gamma of 1012, we have 1011 factorial. This is going to be times 1010 factorial. Over in the denominator, we're going to have 2022 factorial. And of course, we could try to do some canceling or simplification, but I think it's just going to make a bigger mess. So I'm just going to leave it the way we have it. So we'll stop it there. Thanks everyone for watching. Have a great day.